In this video, I'll give an intuition behind this formula, distance between a point and a line. Suppose that you were given the following line that's expressed by this equation, 3x plus 2y minus 4 is equal to 0, and this point right here, 10, 5, and you want to find the distance between this point and this line. Well, what I do is I mentally create create some space, and I bring this line over here, and I flatten it. So this is going to be 3x plus 2y minus 4 is equal to 0, and I carry this point over here. So that's going to be 10, 5. Then what I do is I rewrite this into the familiar y equals mx plus b expression. So let's see here. So that's going to be 3x plus 2y is equal to 4. And then that's going to be 2y is equal to negative 3x plus 4. So then that's going to be equal to y is equal to negative 3 divided by 2, x plus 2. Okay, so why did I do this? Well, let's recall first the definition of slope. I did this so that I can see what's the slope. The definition of slope is rise over run. And what does this mean, negative 3 divided by 2? Well, it's saying that in order to create this line right here, what we do is we start from a point, let's say up here, and we go 3 units down, and then we go 2 units over, and then we draw a line. So you see that we actually, this 3 and 2, the coefficients of x and y, they actually form the legs of a triangle, where the hypotenuse is the resulting line that we have right here. So this, what I'm saying is that this line segment right here, if we draw it over here, let's say these two lines correspond to one another, its length is actually the square root of 3 squared plus 2 squared. And you can imagine that we have a bunch of these lines right here, and they all have the same length, right? And they all have the same length, the square root of 3 squared plus 2 squared. Okay. The next thing that I do, that I think about, is I think about, instead of having one line like this, I have multiple lines that are parallel to the original line. And I draw them right here. And how do we create these parallel lines? Well, we can shift the y-intercept. We have the same slope, but we just shift the y-intercept. So instead of y equals negative 3 divided by 2x plus 2, I shift the intercept up by 1. So that will be 3. Negative 3 divided by 2x plus 3. Or if we express it in this form, it'll be 3x plus 2y minus 4 is equal to 1. So that's this line right here. It's equal to 1. And similarly, we can have another line right here. And that's 3x plus 2y minus 4 is equal to 2. Okay, cool. Now, so what am I doing on this right-hand side? Well, I'm really creating another coordinate system, because the original problem that we're asked to solve, what's the distance between this point and this line right here, I find that it would have been rather convenient if we were asked a question, what's the distance between this point and this x-axis right here? Then that would have been easy. We could have just read the answer directly from the point. That's 5 right here. But I'm using this idea to create this second coordinate that'll help me think about the intuition behind this formula right here. Now, if I'm going to create a second coordinate system, the two coordinate systems, they have to correspond to one another. And right now they don't really correspond because if you think about it, each one of the x-axis on our coordinate system, it has a length of square root of 3 square plus 2 square. Whereas in the original coordinate system, let's say that this is one of the cell of the original coordinate system. The x-axis has a unit of 1, the y-axis has a unit of 1. But how do we have these coordinate systems correspond to one another? Well, what we could do is we can constrain the area to be the same. What do I mean by that? Well, this coordinate system, this is one of the cells from this coordinate system. What is this area? Well, it's 1 times 1 is equal to 1. So if we want to have these coordinate systems correspond to one another, then that means that we have to make this length right here. We have to make this length right here 1 divided by the square root of 3 square plus 2 square. Right? So that if we take this guy, if we find the area of a cell in here, then we'll have 1. That'll be 1 divided by the square root of 3 square plus 2 square times this guy right here. And that'll equal to 1. Okay. So then, what this formula is really saying is, take this point that you're given and imagine that you're going to plug it in to this equation right here, because imagine that this is, let's call these levels. So this is the 0th level, this is the 1 level, the 2 level, and find what level this is on. But then scale it down, adjust for it, because the distance between each level is not 1. It has a unit of 1 divided by the square root of a squared plus b squared. So that's what this formula is really saying. So if we do that, let's go back to here. If we plug this guy into this equation right here, we'll get 3 times 10 plus 2 times 5 minus 4. So then what is that going to equal? That's equal to 30 plus 10, so that's 40, minus 4, so that's 36. So this point, if we think about it on this new coordinate system, it's really on the 36th level, so to speak. But each distance between each level is not 1 unit. It's this guy right here. So we have 36 times 1 divided by the square root of 3 square plus 2 square, or 36 divided by the square root of 13. Yep. So hopefully that gave you some intuition behind this formula right here.